All right, so this class or this, well, this is actually a really important class, but what I wanted to do, I've actually added a slide here, which most of you, if you've printed your notes like last night or today, you would have this slide. I added a little practice slide for us to try to calculate the molar masses for some compounds. Now remember, the molar mass of a compound is found by multiplying the number of atoms present by that atom's molar mass, and then you add them all up. So basically, the molar mass is the sum, the total masses of all of the elements in your compound. The molar masses are the same as the atomic mass. The units are grams per mole. So everything we need is on the periodic table. So when you guys were waiting for me to get started, I asked you to try these two problems. So let's look at the answers to them. How am I going to do this? I'm going to open up my periodic table on my own. I have another screen in front of me. So I'm going to open that up and we'll add these together. So what I do is I'm going to look at the mass for magnesium. So let's write that down, Mg. And you find magnesium on your periodic table. It's in group 2, and you'll find that the molar mass for that is 24.3050. Again, the units for molar mass are grams per mole. Okay, now I also have 2 chlorines. So I'm going to take the mass for chlorine, 35.453 grams per mole. Oops. And I'm going to multiply that by 2. The reason I multiply that by 2 is because there's 2 of them, right? So, okay, let me go back to my red pen here. So this stays the same, 24.3050. And this one, now I'm going to have to use my calculator here. I haven't done these, so I'm kind of doing them along with you. I get 70.906. And then you just add them up, and that's it. So now be careful with your significant figures. So let me just add these up. So my calculator, actually my calculator, interestingly enough, actually tells me the answer for this, 95.211. And sorry, when I say my calculator actually tells me the answer, I mean it actually gives me the correct number of sig figs, significant figures. Remember, when you add numbers together, you take the lowest number of decimal places. So my answer has 3 decimal places. So there we go. There is my molar mass for magnesium chloride. Now, between us, if you are doing an assignment or you're doing this, in another course, maybe you move on to another chemistry course, and you just need a quick molar mass. There, in the future, there are 2 ways you can get a really quick molar mass. In the chemistry lab, the molar masses are typically written on the bottle of the chemical. So if you went into our chemical room in the back and you picked up a bottle of magnesium chloride, typically the brand, whoever sells the chemical, puts the molar mass on the bottle. The other thing you can do, honestly, and again, this won't really work for a test or an assignment where I'm considering or hoping that you guys do significant figures. But another thing you can do is you can just go to Google, right? And if you type in magnesium, sorry guys. magnesium chloride. You could even type MgCl2, it doesn't matter. If you can see on my screen here, this is why I love Google. Whoops, oh my gosh, something's going on here. With my computer. Okay, sorry, share this again. Hold on. Sorry, guys. Technical difficulties here. You can see on the right side of the screen that I have magnesium chloride here, and then the molar mass is actually written right here. Sorry, I had to use my mouse for that. My pen was being really weird. It also tells me the melting point, the boiling point, the chemical formula, all sorts of things. So, you know, in the future, if you just need a quick molar mass, and you're in the lab, you can look on the bottle. If you need a quick molar mass and you're not in the lab, you can always try Google. All right, let's look at the other one. The other one's a little bit more complicated. Okay, so I go back here. What about this other one, copper 2 sulfate? Now, all right, I'll see if I can kind of fit it in over here. Okay, so for this guy, let's write down the masses of everything. So, okay, we have 2 coppers. So I'm going to find the molar mass of copper. Again, it's the same as the atomic mass. So 63.546 grams per mole. Now that gets multiplied by 2. I have 1 sulfur. So sulfur is 32.065. Okay. And when you're doing this on a test, by the way, you don't need to show me all the workings or anything. You can just kind of write the answer if you're comfortable. So oxygen is 15.9994 grams per mole. Now I multiply that by 4 because there's 4 oxygens. All right, let's see what I get. So 2 times copper. So I get 127.092 grams per mole. Sulfur stays the same. You don't have to put your units in every time as well. You can just put them in at the end if you want to save room. Okay, and 4 times oxygen. $63.9976. Now all I do is add up all of those numbers, okay? I have 3 decimal places, so my answer can only have 3 decimal places. And I get a larger molar mass than the last time. I get 223.1, sorry guys, 223.155. I'm rounding it to 3 decimal places. Grams per mole. All right, there we go. That is how you calculate molar mass. Again, you add up all of the elements that are in your compound. Remember, if you have 4 or 5 or 6 of these elements, to multiply them by the number that you have, and then you add them all up. All right, does anybody have any questions on that? If not, we'll move into the next part. All right, cool. Okay. So, next part. This part will basically help you finish the rest of your lab. Oh, I might have a question here. Okay, thanks, Justin. So this part will help you with the final part of your lab. So if any of you have looked at your lab yet, you have unlimited time. You have the whole week to do it. The questions are either calculating the number of particles, the number of moles, or the mass. And there's one more formula I wanted to show you today, and it's this one. Now, in your data book, it's written as this guy on the bottom. So as I mentioned yesterday, you guys are expected to know how to rearrange these formulas. So the formula is the number of moles is equal to the mass of your element, or compound, I should say, divided by the molar mass of that compound or element. It could be either or. In your formula sheet, it's written like this, that the mass of your chemical is moles times molar mass. So here, let me break this down for you guys. So N is mole. M is mass. That makes sense, doesn't it? We use a nice M for mass. And MM is molar mass. All right, so let's do some practice with this. And again, this will get you ready, completely ready for that lab number 7. Okay, so I have the answer written here, but let's kind of pretend that I don't. How many moles are there in 76.5 grams of iron 3 oxide? This is a really important question for quizzes, final exam. I mean, this is super important. How many moles are there in 76.5 grams of iron 3 oxide? So there are 2 steps before you even start this. The first step is to find out the formula for iron 3 oxide, right? What is iron 3 oxide? I have the answer written below, but just a little review. Iron 3 is Fe3 plus, oxide is O2 minus. How do I know it's 2 minus? Well, we did this in chapter 3. It's in group 16 or 6A, and everything in group 16 or 6A is 2 minus. The Roman numerals here tell me the charge on my iron. So iron 3 is iron 3 plus, oxide is 2 minus. Now, remember that trick I showed you? I'm going to erase this in a second, guys. So if you're kind of writing this down, go a little quick because I don't have room for all of this. But remember my method, I guess it's not my method, but a method in chemistry is this crisscross idea where I can take the charge on the oxygen and put it here as a subscript for the iron, and I can take the iron charge and put it on the oxygen. So my formula for this compound is Fe2O3. If you're not familiar or you don't like that method, just remember 2 irons will give me a charge of +6. 3 oxygens will give me a charge of -6, and the charges cancel. And that's what you do for every ionic compound. I'm not going to spend any more time on that because, excuse me, you did this in unit 3. Okay, so guys, okay, let's put up the answers. I'm going to have to erase some of my writing in a second. Okay, I'm going to have to erase this part at least. I'll get rid of the bottom part. So there's my formula, F2O3. So that's step 1. Step 2 is to calculate the molar mass. Now, okay, how do I know I need to find the molar mass? Well, let's look at the question. The question is asking me how many moles. So the question is asking for N, and it's giving me mass. So think about your 2 formulas that you've learned so far. We learned that number of particles is moles times Avogadro's number, And we've learned that mass is moles times molar mass. Think about those two formulas. Like if you had this question on a test or a final, think about those two formulas and which one would you use? In this question, there is no mention of particles or atoms or formula units or molecules. This question gives me the mass. It's asking for moles, and I always have molar mass. Molar mass, like Avogadro's number, is a constant that you will always have. As long as you know the chemical, you know the molar mass. So I would obviously need to use this formula on the bottom here that I'll circle in purple. Right? The other formula doesn't work. I don't need particles. I don't need Avogadro's number. So if I'm going to use that formula, step number 2 has to be to calculate the molar mass. So I add together 2 irons, 3 oxygens, and I get my molar mass. So the molar mass of iron 3 oxide would be 159.668. And then what I do is I plug all of my information into my formula. So moles equals mass over molar mass, right? So my mass is 76.5. My molar mass is 159.688, and I divide. And the unit for moles is, of course, mole, M-O-L. And there we go, that's it. Pretty easy, but if it's your first time ever seeing this in your life, it can take a little bit of practice. There are worksheets that have answers that I'll be putting online after today's class. Worksheets for Unit 4 where you can practice this, but it's pretty easy. In terms of the formula, I guess I should say it's easy, but there are things you need to consider. So let's look at another one. Basically, I want to show you maybe 3 or 4 examples today, and then we're done. Oops. That's 1:55, so we got lots of time. Okay, what about this example? Example number 2. How much mass does 2.5 moles of carbon dioxide have? So how much mass does 2.5 mole of CO2 have? Well, I guess I kind of ruined... Sorry, guys, something stuck in my throat there. I guess I kind of ruined step 1. The first thing you need to do for this example is, well, what is carbon dioxide? Because, again, if you look at the information the question is giving me, it's asking for mass, it's giving me moles. So immediately I know the formula I'm going to need to use is this formula. If it doesn't mention particles, formula units, anything like that, don't use the Avogadro's number formula. Use this formula. There's only 2 formulas so far. There will be a third by the end of this chapter, but we only need to know 2. Okay, well, if you look at this equation I have circled up on the top here, I'm looking for mass. They gave me moles, so I'm going to need to find molar mass first. So step number 1 is figure out what carbon dioxide is. What's the formula? If we don't know the chemical formula, we cannot find the molar mass. So step 1, get the chemical formula. Step 1. Step 2 is find the molar mass. Now, guys, just a little heads up. Typically, on a final exam, step 1 is done for you, meaning we would just give you the chemical formula. On a final exam, you will have a question that is only about naming. And then this question on the final exam, and again, this is definitely a good question. we would probably give you step one, meaning I would just say, how much mass does 2.5 moles of CO2 have? So if I give you the chemical formula, your next step is to get the molar mass, which is here. Again, what I did for the molar mass is I added 1 carbon and 2 oxygens. So I add together 1 carbon with 2 oxygens, and I get 44.0095 grams per mole. Now, in this step here, I just use my formula from my data booklet. Remember, guys, these formulas are in your data booklet. I take my moles from my question, 2.50 moles. I multiply it by my molar mass, and I get 110 grams. Actually, if I'm going to be fancy about this in terms of significant figures, I should probably say 110 with a decimal grams. If you're wondering why it's grams, well, moles cancel, and you're left with grams as your unit. 3 significant figures because the question has 3 significant figures. That's another good hint I guess I should have mentioned on the last slide, is 99% of the time, if you want to know how many significant figures to put in your answer, choose the smallest amount in the question. 99% of the time, that will work perfectly. So my question is giving me 3 significant figures, so my answer has 3 significant figures. Another thing to remember is don't stress too much about significant figures. In the past, I've had students like, we used to take off a lot of marks for significant figures, like 5, 10%. Now we only take off a couple of percent, like 1 or 2. I mean total. So if you guys did your final exam and you got every single significant figure wrong, but everything else right, you would still probably get a 97 or 98. We don't take off as much marks as we used to for significant figures, so don't stress about them too much. It's total, it would be worth a couple of percent, 1, 2, maximum 3 of the total test, not the question. All right, before I move on, because the next question I'm going to do is a little bit more complicated, is everybody okay? Does anybody have any questions about this before I move on? I'm just doing like a feedback check because this is very important that you understand this. All right, nothing yet. Okay. This last section, and I might have time to do both examples, this last section of 4.2 is literally as hard as they get, and it's not that hard. But we can put all of this together now, okay? So what do I mean? Well, let's look at this slide here. There we go. Oops, I went too far. We know so far 2 formulas. The mass of a compound is equal to moles times molar mass. So mass equal to moles times molar mass. We know that formula. We also have this one, particles is equal to moles times Avogadro's number. Okay. But we can use them both because they both contain moles. So what do I mean? Well, imagine if I give you the mass and then ask you to find particles, or I give you particles and ask you to find mass. You will have to use both of the formulas in 2 steps, and I'll show you this, and this is on your lab. I don't need to say your, I just say on lab 7. You do have to look at this in lab 7. It's worth 3 marks of lab 7, so it's a really important part. All right, what am I talking about? Okay. Now I have the answer, but before I show you the answer, let's make a plan. Let's think about this problem. How many molecules are in 3 grams of nitrogen gas? Okay, so again, like I said, let's make a plan. The question is asking for N, capital N molecules. Remember, capital N or uppercase N could be particles, molecules, atoms, okay, or formula units. Formula units are what you would call an ionic compound. So if you ever see molecules, atoms, formula units, particles, use big N. And the question gives me mass as M. Now think about the problem I have here. I am trying to solve for capital N. I know it's moles times Avogadro's number. But look at that equation. So guys, look at the top right of my screen where I have the formula. I have Avogadro's number. You always have Avogadro's number. It's a constant like gravity. But there's a problem. I don't have moles. I cannot solve this problem because I don't have moles. There's a question I'll get to in the chat in 30 seconds. So I don't have moles. What am I going to do? Well, they did give me mass in my equation. So what I can do is I can use this equation to find moles and then put it in here. Okay, I hope that makes sense. So using the mass and molar mass, I can calculate moles first, and then I can actually solve the equation to find particles. All right, and I'm going to show you this now in a second. There is a good question in the chat here. Aisha asks, how many digits do I need for everything? Talking about rounding up. Aisha, you use significant figures, so I can't tell you how many digits you need because it depends on the significant figures in the question. Okay, so just like we did in chapter 1, you use significant figures to calculate how many digits are in your answer. So for this problem, I can tell you right now, I would have 3 significant figures in my answer because the question is only giving me 3. So 3 digits, 3 significant figures. All right, so let's look at my answer. This is not my favorite way to do these slides, by the way, but this is kind of what the other instructors have done. This kind of has like 4 steps if you think about it. And this one's a little challenging because you need to remember nitrogen gas is N2. When you have nitrogen gas in nature, it's a molecular element. We did this in chapter 3. Nitrogen gas is in N2. Oxygen gas, O2. Chlorine gas, Cl2. We did this in unit 3. So there's a kind of a lot of things to consider here. So step number 1, what is nitrogen gas? Well, it's N2. So first thing I do here, and typically, guys, I would give this to you on a test. Okay, so step number 1, calculate the molar mass of N2. So the molar mass of N2 is easy. It's 2 times the molar mass of nitrogen. So 2 times 14, and we get 28. All right, to go back to Aisha's question about digits and significant figures, don't round until the end. So I'm going to keep all of my digits here. All right, step 2, calculate your number of moles so you can solve the question. So moles is equal to mass over molar mass. That's just the formula from my data book rearranged. Oops, sorry guys. Sorry. I changed some settings. I don't know what's going on here. Sorry, I changed some settings on my pen and trying to get rid of those lines that come up, and I think I'm going to have to go back to normal. Anyways, so step 2, I know the mass of nitrogen. I know the molar mass of nitrogen now, so calculate the number of moles. Again, don't round until the very end. So I get my number of moles. And finally, in step 3, and this is why this is worth 3 marks. So if you're doing this on lab 7, it's worth 3 marks. So it's worth a lot because there are 3 steps. Find the molar mass, calculate moles, and then put it into your equation to calculate particles, or in this case, molecules. So I just take my number of moles and I multiply it by Avogadro's number. I think I spelled Avogadro's number wrong last time. Avogadro's number. Okay, multiply them together and you'll get your answer. All right, any questions on that? Now I'm going to show you one more and then I'm pretty much out of time. But if anybody is still confused about this, I can do another one tomorrow afternoon when we have class, or I guess some of you might have class in the morning tomorrow, depending on your section. But if you're still confused and you don't feel ready to do lab number 7 tonight or whatever, I can do another example from this tomorrow. So, don't panic today if you really don't get this. So before I move into the final example, are there any questions on this example? This is as hard as it gets, literally. All right. Okay. I think, guys, tomorrow when I do an example, I'll do it from scratch, meaning I'll do it like without the answer written. I'll do it myself, so you guys can kind of work along with it with me. Okay, so this will be my last example for today, and then we're done. You guys are officially ready to start your lab. Well, I mean, you could have done your lab anytime especially if you've done chemistry before, but now you have all of the information needed for your lab. So let's look at this question. Again, let's break it down. Let's kind of solve this puzzle before we attempt to do the calculations. All right, let's pick a different color. Let's go with green. All right, how much mass? How much mass? So the question is obviously looking for M, mass. Honestly, guys, one of the challenges or the biggest things for this is to know what the letters in your formula stand for, right? Your formulas are in your data book, so you don't need to memorize the formulas at all. What you do need to know, however, is what is lowercase n, what is uppercase N, what is M, right? So part of the challenge here is knowing what variables you're dealing with. So how much mass does, this is bad English here, does or do, I don't know, 5.1 times 10 to the 25 atoms, so that's particles, of zinc have? Now I love this. This is a really good question. Oops, looks like a cyclops there. There we go. Because we don't have to worry about molar mass, right? Zinc is just straight up Zn. You can find the molar mass of zinc on the periodic table. It's 65.409 grams per mole. I don't have to worry about the molar mass of this. Like, I don't have to calculate anything. When you're dealing with a metal, iron, cobalt, nickel, zinc, silver, gold, whatever, you don't have to worry about having 2 of them, like like nitrogen or oxygen. Okay, so here's where the problem lies in this question. It's asking for mass, and I know that mass is moles times molar mass. Well, molar mass I have, but I do not have moles. So I'm at a problem here, right? I have molar mass, I'm looking for moles. So I got a problem. What I can do, however, is I know that I have or I know how many atoms of zinc I have. So what I can do is, whoa, I don't know how I did that, but it looked cool. What I can do, I'll use a light green for this, is use this formula to find moles first, then I can answer this question. So what I would do is use this formula to find moles and plug it in. I say plug it in, I mean put it in my top equation. So let's do it. Step number one, oops, let me pick another color than red. Step number one, find moles. Actually, there's something I always tell my chemistry students in 1120 or 1121 or chemistry 1200. If you are looking at a chemistry calculation, and I'll say this really slow because it's kind of been like a rule that I've lived by as a chemistry student and instructor. If you're looking at a chemical calculation, so it's not naming, it's not Vesper, but it's about calculations, and you do not know what to do, you have no idea what to do, I'll tell you a hint. If you don't know what to do, calculate moles. Somehow use one of your formulas to find moles. And that is basically your first step in most problems. Now, you might need to calculate the molar mass first. But again, if you don't know what to do on your final exam, calculate moles. You will get marks. You might not get full marks, but you will get marks. So my saying is, when in doubt, calculate moles. All right, I cannot stress that enough. If you don't know what to do, and I've been there, trust me, when I was a student, sitting there looking at a paper confused, if you don't know what to do, find moles of something. So step number one, my formula, N is particles over Avogadro's number. I just put in my numbers here. To kind of go back to Aisha's question about significant figures, here we only have two significant figures. So my answer will be very small. It will be two significant figures. So step number one, calculate moles. Moles is particles over Avogadro's number, like I said. I get 84 moles. That's a really big number. A seal in the chat asks, where did I get this number? On the bottom, this is, if you remember yesterday's class, this is Avogadro's number. Avogadro's. It is a constant. It's in your data booklet. Na, Avogadro's number or Avogadro's constant, is like gravity or pi. It is in your data booklet. It's a constant. Again, if you're in physics, it's like gravity. It doesn't change. All right, so divide those out and you'll get your moles. Step two, I'm going now, okay, well, arguably you might say, okay, well, step two, we got moles, we can do this problem, but really you're still not ready to do this because you need molar mass first. So step two, get your molar mass of zinc. And then in step three, put it all together. Mass is moles times molar mass. So I have moles, I have molar mass, just multiply them together and you'll get your answer. So all I'm doing is using two formulas here. I'm using the first formula to calculate moles. Then I'm using the second formula to answer the question, to calculate the mass. All right, is that okay? Now, again, if anybody sitting here is really, really lost, I will do some more of this tomorrow, maybe just another example, because we do have to move kind of through this unit. But if I suggest that if you are very confused right now, come to class tomorrow. I'll do another one. And if you're still confused, I'll have some worksheets with answers up tonight that you could try, over the next week or two to make sure you figure this out. One thing I want to mention before I leave you guys, okay, is I just want to open a white screen for you. your data book gives you two formulas. It gives you this formula, and it gives you this formula. You guys need to know how to solve for moles or rearrange them. So I don't care what you do, you can like use algebra and kind of understand what's happening, or you can just straight up memorize them. But it's not in your data booklet. This is not in your, oops, I had a typo there. It's not in your data booklet. So you guys should know these formulas here. You can memorize them, you can use algebra to calculate them, whatever you want, but the data booklet gives you these two. You need to know how to rearrange them, and that's up to you. Okay, again, it's just algebra. And you know, if you hate algebra, you just have to memorize it. Okay, so guys, I have another class in 10 minutes, so that's it for me today. Well, I'll hit stop record. So have a great day. You guys can go if you don't have any questions.